Hello everyone. Hopefully all is well. This is another video lesson. This lesson is going to be over volume by cross sections. This is a review, so I'm going to move pretty quickly through this, and hopefully the video is helpful to answer all your questions. All right, so let's read this together. It says, find the volume of a triangular shaped solid whose base is the region bound by the lines f of x is equal to 1 minus x over 2, and g of x is equal to negative 1 plus x over 2, and x is equal to 0. And so you can see here, this is the base of the solid. And so this is the line here, which is the y-axis. X is equal to 0. Then we have the line here, which is 1 minus x over 2. This is just the y-intercept of 1 and a slope of negative 1/2. So we go down 1 and over 2. So we get that line, and then we get the next line is the y-intercept of negative 1, and the slope is positive 1/2. So we go up 1 over 2. So that's how we get this line. And so it creates this shape. And we want to find the volume created by cross sections that are square, and these squares are perpendicular to the y-axis. So if it's a line that's perpendicular to the y-axis, that we know that our rectangle, I'm sorry, not our rectangle, but our squares are going to be um, laying down horizontally. So if you can see here, we're going to have to find the base is going to be right minus left. And so since it is perpendicular to the y-axis, we're going to need to do in terms of y. So this is going to be dy. And so now that means that we're going to have to take this function and solve for x so we can get our function in terms of y. So I'm going to briefly go through this. I know everyone will be able to do that. And so I'm only going to do the first one, and hopefully you will be able to look at what I did for the first one and go on with the second one. So I'm going to go ahead and take the function y is equal to 1 minus x over 2 and go ahead and solve for x and get x by itself. So since this was a negative x over 2, I just moved it to the other side of the equal sign, and that's where I got the positive. And so you don't have to do it this way. This is just the way I wanted to do it, just to go ahead and get x positive. If not, at the end, you could have just multiplied both sides by negative 1, but I didn't want to do that. So I went ahead and moved the negative to the other side. It became positive. So now I'm going to take y and move it to the other side. So I now have 1 minus y. And so now to get x by itself, I'm just going to multiply both sides by 2. So I know this top function here is going to be, now this is going to be, this function right here is now going to be 2 minus 2y, because I went ahead and written this in terms of x. And then the lower function is going to be 2y plus 2. And I'm not going to go through this one because it follows the same pattern. And so this lower function is going to be 2y plus 2. So now I need to go ahead and find the volume. So since I want to find the volume, and this should be in your notes, I didn't rewrite this. I am going to, in order to find the volume, you take the integration of the cross section. Now be careful because this is dy, so we're going to be integrating using our y values. So we're going to be integrating from negative 1 to 1. But if you notice, if I go from negative 1 to 0, then I'm using the bottom half. So that's going to be the function 2y plus 2. So that's where I get the 2y plus 2 here. But keep in mind, we're taking the area of the cross section. So if you see here, the base of my square is going to be the distance from the right function to the left. So my right function is 2y plus 2. But since this is the y-axis, it's really going to be minus 0. So I know my base here is just going to be 2y plus 2. But if you want to find the area of a square, you have to take the base and square it, because the base and the height in the square is the same. So that's why I have 2y plus 2 squared. And then I'm going to be integrating from -1 to 0. And then if you look here, if I go from 0 to +1, I now have this function, 2 minus 2y, right? Because I'm going right minus left. But this is just going to be 2 minus 2y minus 0. So the base here is just 2y. I'm sorry, 2 minus 2y. And again, since it's a square, I have to go ahead and square that. And so I set the integration up, and then I'm going to show you this. I'm not going to go through everything for time's sake, but here, when I'm going to have to expand this statement right here out. So I have 2y plus 2. I need to FOIL that out. And then I have 2 minus 2y, and I need to FOIL that out. Hopefully everybody knows how to FOIL. You can definitely stop the video just to verify here. So I FOIL this out. And now once I FOIL it out, since this is integration, I'm going to have to take the antiderivative. And I'm assuming that you guys still know how to take the antiderivative. Since this is y squared, I add 1 to the exponent, it becomes y cubed, but I still need to divide by the new exponent, which is 3. And in this case, be careful, because this is y to the 1. I'm going to add 1 to that and get 2, but I'm going to be divided by 2. So 8 divided by 2 gives me 4. I don't have any variables here. So since I don't have a variable here, when I take the antiderivative, I need to add a variable. So that's where I get the 4y. And likewise, you can, again, stop the video and just verify here. But I did the same thing on the other side. Remember, I had to do this twice because we have 2 integrations, because we had to separate the integrals because we had 2 different functions. All right, so now I'm going to plug in 0 first, because that's the bigger number. And since everything has a y in it, that's where I get the 0. And then I'm going to have minus when I plug in a -1 here. So that's just going to become -4/3. But a negative times a negative is a positive. So this becomes 4. And then this is 4 times -1. So this just becomes -4. So you can see here I have 4 minus 4, so that goes away, and a negative times a negative is a positive. The 0 goes away, so this first half is going to give me 4/3. And if you look here, this is where I get the other 4/3, because I get 4 minus 4. That gives me 0 plus 4/3 minus 0. So they just basically goes away. And I have 4/3 plus 4/3 would give me 8/3. So the volume from the cross sections of squares that are perpendicular to the y-axis for this particular base is going to be 8/3. Okay, so let's look at one last example, then we'll be done. We're going to use the same base, but this time the cross section is going to be a right isosceles triangle where the hypotenuse is bounded by the region and perpendicular to the x-axis. So, like I said, this is a review, but I'm just going to recap. If you have the area of the right isosceles triangle when the base in this case is going to be, or when the hypotenuse is stuck between the 2 regions, then it's going to actually be, the area is going to be equal to 1/4 times the hypotenuse squared. Because remember, if they give you the hypotenuse, how do you find a side? You have to divide by the square root of 2. But once you square the square root of 2, that just becomes 2, and 8 squared is just 8 squared. So I have 1 times 1/2 times h squared over 2. And so 2 times 2 is just going to be 4. So that's why I get that 1/4 h squared. So let's look here. This time is perpendicular to the x-axis, so we know we're going to have to do dx. So in this case, we're going to have our top function minus our bottom function. So that's going to be our base. This is what the hypotenuse is going to be. So my hypotenuse is going to be this length right here. So I know the hypotenuse in this case is going to be my top function, which is 1 minus x over 2 minus my bottom function, which is -1 plus x over 2. So that's just this one right here. That's this line right here, and this is this line right here. Now remember in the other example, we had to go from x's to y's because it was perpendicular to the y-axis, but this time it's perpendicular to the x-axis, so we can keep the x's. So here when we subtract these, a negative minus a negative becomes a positive. So this is 1 plus 1, which gives us 2. And then we have a half of x and a half of x. So this becomes -1/2 of x, and this is -1/2 of x. So a half and a half just give us a whole. So that's where we get the 2 minus x. So we know our hypotenuse is equal to 2 minus x. And so in order to find the area, we have to do what? Multiply by 4 and then square the hypotheses. So that's why here we have this 1/4 out here. I went ahead and took the constant out. And this time, since we're integrating, since it's perpendicular to the x-axis, I know that these are going to have to be x values. So I'm going to be integrating from 0 to 2. So I'll integrate from 0 to 2. Then I have to square the hypothesis. I'm sorry, the hypotenuse. And so I did not FOIL this one out already, and I did not set up do the integration. I'm going to go ahead and FOIL it out real briefly, and you can just practice with the integration for yourself to make sure you get the right answer. So I'm going to square the first term. That gives me 4. Then I multiply these two together and double that. So 2 times a negative x is -2x. But if I double it, that's -4x. And then I'm going to square my x. So that's x squared dx. And of course, I have to take the antiderivative of that. First plug in 2. And I guess we can go ahead and at least take the antiderivative. And then I'm going to let you do the rest on your own. The answer should be 2/3. So if I take the antiderivative, that gives me 4x minus, and keep in mind, I'm going to raise this to the second power now because it's to the first. So that's just going to give me 2x squared because I'm going to be dividing by 2. And then this is going to give me x cubed over 3. And I'm going to evaluate that from 0 to 2. And anyway, I'm going to stop here because I feel like you can go ahead and plug in 2 everywhere you see an x. And then when you plug in 0, that side is just going to go away. So, and once you get through plugging that in, you should end up getting 2 over 3. That is the final answer for that. So the things that you need to make sure that you are paying attention to is what cross sections are being used. You can use right isosceles triangles. You can use semicircles. You can use rectangles. You can use squares. In this example that we looked at, we only did isosceles right triangle where the hypotenuse was what was bounded between the region. And in the example that I'm going to give you on your quiz, you're not going to be using the hypotenuse. You're going to actually be using a leg. So you need to be careful with that. And so in this case, we had it perpendicular to the x-axis, and then you have other cases where it could be perpendicular to the y-axis. So be clear that you understand the shape that you're using for the cross section and which axis it is perpendicular to. All right, thank you guys. Hopefully this video was helpful. Please, if you have any questions, go ahead and email me. and hopefully all is well with you guys. Thank you. Have a great week.